Hey there, hope you're having a wonderful day. In this video, we're going to be coding the game Space Invaders. So what you see here is the final product. So if I refresh, you can see we start off with 6 aliens and they move side to side. I can also move the player, which is the spaceship. So every time the aliens touch the edge of the screen, they reverse course and they advance 1 row. And I can fire at them by pressing the space bar. And the nice thing about this game is that every time you clear a group of aliens, a bigger group appears. So the goal of the aliens is to reach you, and you have to fend them off by firing the bullets at them. And so you can keep on playing and seeing if you can increase your high score. And the game is over when the Space Invaders, or the aliens, eventually reach the same row as you. So as you can see, they're advancing and then game over. Okay? So before we begin coding, I just want to mention that I am working on a web dev tutorial series where I create fun game projects using HTML, CSS, and JavaScript. So you can also see the list of tutorials available on kenyipcoding.com. And these are all the tutorials available on my channel. I have a tutorial on Wordle, Sudoku, 2048, Minesweeper, Candy Crush, Snake, and many more to come. So if this is something that you're interested in, make sure you subscribe to the channel. Alright, let's begin. Before we start writing code, you should get your images from the GitHub repo link down below in the video description. So there are 4 alien images. For this tutorial, we're just going to use one of them, so the white colored one, and there's also the ship, which is the player. So download the repo and get these 5 images and copy and paste them into your folder. Alright, so now that you have those images in your folder, start by creating 3 files, index.html, space.css, and space.js. So the HTML is going to be very simple. We're going to have doc type HTML, HTML. We're going to have a head tag, and we're going to add some standard stuff. So meta car set is going to be UTF-8. Meta name equals viewport. Content is equal to width equals device width. Initial scale is equal to 1.0. Next, let's add a title for our web page, and it's going to be called Space Invaders. Now let's link our style sheet. href is going to be space.css. And let's also do the same for our JavaScript file. So script source is going to be space.js. Alright, that's it for our head tag. In our body tag, we are going to add a header, Space Invaders, and then we're going to add a canvas and give it the ID board. By giving it an ID, we can access this using JavaScript so that we can draw on the canvas. Alright, let's move on to the CSS. So it's going to be very simple. In the body, we're going to add a font family of Courier new, and we're going to do text align center. So this is going to align the header and the canvas to the center of the page. And for the board, we're going to add a background color of black. And that's it for our CSS. So this is what we have so far. We have our header and we have our canvas, and as you can see, the background color is black. Alright, in our JavaScript file, let's add some variables for the board. So we're going to have a tile size of 32, and we're going to have 16 rows and 16 columns. So in a bit, I'll explain what these numbers mean, but just continue along. So for the board, we're going to have a variable, and we're going to set the width to tile size times the number of columns. So this is tile size 32 times 16 columns. And we're going to do the same for the board height. Tile size times the number of rows. So this is 32 times 16. And then we're going to add a variable called context, and this is what we're going to use to draw on the canvas. Alright, so when the page loads, we are going to call a function, and we're going to do board equals document.getElement by ID board. So the element within ID board is our canvas tag. So this variable board will be accessing that canvas tag. Next, we're going to set the board width to board width and board.height to board height. And then we're going to get the context, which is board.getContext 2D. So this is used for drawing on the board. Alright, so if I refresh the page, you can see we have a bigger canvas. So just to recap what we just did, we have a tile size. So each tile is 32 by 32, and we have 16 columns and 16 rows. This means in total we have about 256 tiles. We have 16 tiles down and 16 tiles from left to right. And the height is going to be 32 pixels times 16, which is 512. And same thing for the width, 32 times 16, which is 512 pixels. So what you see here is a canvas of size 512 times 512 pixels. Okay? Alright, now that we have our board, let's draw our ship. So here I'm going to add some variables for our ship. We're going to do let ship width equal to tile size times 2. And we're going to do ship height equal to tile size. So tile size is 32 pixels, so the height is 32 pixels, and the width is 64 pixels. So this is actually the actual dimension for our ship. Now we need to have an X and Y coordinate for our ship, so we know where to place it. So ship X is going to be tile size times columns divided by 2 minus tile size. So I'll explain this in a bit. And for ship Y, it's going to be tile size times rows minus tile size times 2. And then let's also add a ship object just to be a little bit more organized. So let ship equal to, we're going to have an X property, which is ship X, Y is going to be ship Y, width is going to be ship width, and height is going to be ship height. So we mentioned that X was tile size times columns divided by 2 minus tile size, and the Y is tile size times rows minus tile size times 2. So let's start with the Y. So Y is vertical, right? So if we did tile size times rows, we end up here. And we want to be on the second to last row, so that's why we do minus tile size times 2. So we're going to go up 2. So this is somewhere, this is going to be the y-axis for our ship. Now we need to figure out where to place the X position. So ideally we want the ship to be in the middle of the page. The thing is, the width of the ship is 2 tile sizes. So if we take the columns divided by 2, we have 16 columns. 16 divided by 2 gives us 8. So we would be over here, right? We would be over here for the x-axis. But the thing is, again, the width of the ship is 2 tiles. So you can see it's not balanced. When we draw the image, we always start on the top left corner. So here we have 1, 2, 3, 4, 5, 6, 7, 8 to the left, and 1, 2, 3, 4, 5, 6 to the right, which is why we subtract the tile size. When you subtract, you go backwards, so you go to the left, So we shift the tile one over. So we shift the ship one tile over so that it would give one tile to the right side. So after we've done that, the X will be on the column 7, and we would draw the ship over here. Okay, so it's going to be right in the middle of the screen. Alright, so let's draw the ship. So here I'm going to do draw initial ship, and we're going to do context.fill_style. We're going to set it to green. So this will change the pen color to green. And we're going to do context.fill_rect. We're going to pass in an X position, which is ship.x, a Y position, ship.y, a width, so ship.width, and a height. Okay. Alright, so when we refresh the page, you can see we have our green rectangle, which is our ship, and it is where we said it would be. Okay. But because we have our ship image here, we don't need this. Instead, we're just going to load the image. So over here, I want to add a ship image variable. And then down here, I'm going to load the images. So ship image is going to be a new image. And we're going to set the image source to /ship.png. Okay, so don't forget the extension. And to draw it, we're going to do context.drawImage. And it's similar to fill_rect, except you need to pass in an image. So it's going to be ship image, ship.x, ship.y, ship.width, and ship.height. Alright, so if I refresh the page, you can see our ship is not visible, and that is because the image has not loaded yet. So what I'm going to do is shipImage.onLoad. We're going to call a function, and inside the function, we're going to draw the ship. Okay. Alright, so if I refresh the page, you can see we have our image of the ship. So now that we have our ship, let's move the ship. So when we move the ship, we are moving it along the x-axis. So it's to the left and to the right. And whenever we move the ship, we change the x position of the ship. So when we change the x position of the ship, we need to draw the new position on the canvas. So over here, right below ship image, I'm going to create a new variable called ship velocity x. And I'm going to set it to tile size. So whenever you move the ship, you're moving it one tile over. So as for redrawing the frame, I'm going to create a function called update. And within our onload function, I'm going to do request animation frame, and I'm going to pass in the update function. And I'm going to do the same inside update. And I'm going to take this line of code and paste it into the update function. So now we are drawing the ship over and over again. Alright, so now if I refresh, you can see we still have our ship, but nothing is changing because we haven't moved the ship yet. But just know we have our game loop. The canvas is drawing the frames over and over again. But because we didn't move, it's just drawing the same thing over and over again. So let's code the movement for the ship. So to move the ship, I'm going to create a function called moveShip, and it'll take in a parameter e, and e stands for event. So this is going to be a key event. So if e.code is equal to arrow left, we are going to take the ship.x and subtract the velocity from it. So this is moving left. Else, if e.code is equal to arrow right, we're going to do the opposite. We're going to take the x position and add the velocity to it. Okay, so this one, remember, the ship velocity x is the tile size. So we're going to move left 1 tile and move right 1 tile. Okay. All right, now that we have our function, we need to add an event listener. So right under here, I'm going to do document.add event listener. It's going to listen for a key down and call move ship. So basically, key down is whenever a user presses the key down. Every time the user presses a key on the page, it's going to call move ship, and inside move ship, we're going to check to see which key was pressed. If it's arrow left, we're going to move the ship to the left, and if it's arrow right, we're going to move the ship to the right. All right, so if I refresh the page, you can see if I press left, we have the ship moving left, and again, and again, and again. And I can also move right. But you can see here, our frames are stacking on top of each other. And the reason is we did not clear the canvas, so we're just drawing on top of the same frame. So let's clear the canvas in our update function. So in our update function, I'm going to do context.clearRect 0, 0, which is the top left of the canvas, board.width, and board.height. All right, so if I refresh the page now, you can see our ship is moving left and right. Okay, and I can just hold on to the key. And there is an issue, and that is we can fall off the screen. So this shouldn't be allowed. So let's add an additional check. So inside our move ship function, I'm going to add a check to see if ship.x minus ship velocity x is greater than or equal to 0. So 0 is the x coordinate for the left edge of the canvas. So before we apply this change, we need to check. If I try to move left now, will it go out of bounds? And let's do the same for arrow right. So we're going to have ship.x plus ship velocity x plus the ship width. Okay, you can't forget the width, and we're going to check to see if it has not exceeded board.width. All right, so now we refresh the page and I go left. You can see I'm tapping the left key, but I can't go out of bounds, so it's not letting me move left. And the same thing, I can't go further past here. So these are our boundaries for the ship. Okay, so now that we have our ship, let's draw the aliens. So over here, let's add some variables for the aliens. So first, we're going to create a variable called alien array, and this will hold all our aliens. And similarly, we want an alien width, which is going to be tile size times 2, and alien height is going to be tile size. Alien x, so we're going to set this to tile size as well, and alien y is also going to be tile size. So this is actually the same as saying tile size times 1. So the starting coordinate for the alien is going to be 1, 1. All right, so I'm going to add another variable for the alien image, and I also want to add the number of aliens that appear in each row and each column. So I'm going to have alien rows, and we're going to initialize that to 2. So we're going to have 2 rows of aliens, and aliens columns is going to be 3. And let's also keep track of how many aliens there are. So alien count is going to start off as 0. So this is the number of aliens to defeat. Currently we have 0. And then let's scroll down and add a function called createAliens. So in here, I'm going to use 2 for loops for let c goes 0, c less than alien columns, c++, for let r equals 0, r less than alien rows, r++. And here I'm going to create an alien object. So we're going to set the image to alien image x to alien x plus c times alien width. And y is going to be alien y plus r times alien height. The width is going to be alien width, and the height is going to be alien height. So these are the properties of our alien. And for the image, let's load it. So over here, I'm going to do alien image is equal to new image. And similarly, we're going to set the source of alien image to /alien.png. Okay? So down here, you're probably wondering, what is this math? So I'm going to show you. All right, so we said there are 2 rows of aliens, and in each row there are 3 aliens. So in our for loop, r and c, r is going to be from 0 to 1, and c is going to be from 0 to 2. Now, the starting position of the aliens is right here. This is where we're going to start creating the aliens, and that is in the position 1, 1. And each alien has a height and a width. So the height is 1 tile size, and the width is 2 tile sizes. So that's going to be where the first alien is drawn. Now we need to figure out the next x position for the next alien. So how do we get here? From here, we take c and multiply it by the width. So c starts at 0, so it's just over here, 0 times width, so there's no displacement. And then we have 1 times width. So x is going to be the starting tile plus 1 times width, which is going to be over here. And then the next one is going to be 2 times width, which is going to start over here. So we're going to create the next alien here. And then after that, our first iteration is finished, so we move on to the next row. So we're going to move on to this row and repeat the same process. So this is going to draw the next 3 aliens within that row. Okay? Alright, so now that we've created our alien, we need to push it into our alien array. And then at the end of our for loops, we're going to set the alien count equal to alien array.length. Okay, so we have our create aliens function. Now in our window.onload function, we're going to call create aliens. Alright, so after we've created the aliens, we need to draw them in our update function. So for our aliens, since we have an array of them, we need to iterate through the array. So for let I equals 0, I less than alien array dot length I++, we're going to get the alien at that index. So alien array of I. And I forgot to mention that down here, we should add another parameter or another property, and that is alive. So we only want to draw the aliens if they're alive. So by default, each alien is alive. So we're going to set it to true. So let's scroll back up. So if alien.alive, we're going to do context.draw image, alien image, alien.x, alien.y, alien.width, and alien.height. Okay. Alright, so now if we refresh the page, you can see we have our aliens on our canvas. We have 2 by 3, so 2 rows of aliens, and in each row, there are 3 columns of aliens. Okay, so in total we have 6. Now we need to make the aliens move. So to make the aliens move, we need to add a velocity. So over here, I'm going to add alien velocity x, and I'm going to set it to 1. So this is the alien moving speed. And within our update function, right before we draw our alien, I'm going to move the alien. So we want to move the alien horizontally. So alien.x, we're going to add the alien velocity x. All right, now if I refresh, you can see the aliens are moving to the right. Now, when the alien touches the edge of the screen, we want to reverse course. So we want to flip the velocity. So over here, I'm going to do if alien touches the borders. So this is the borders of the canvas. If alien.x plus alien.width is equal to or greater than board.width, so it's heading right, or alien.x is less than or equal to 0, which is the left side, I'm going to flip the velocity. So alien velocity x, I'm going to do times equal -1. All right, so if I refresh the page, you can see the alien is moving to the right, and it touched the edge of the canvas, so it's flipping. And then it touched the edge again, so it's going to flip back. Now, what we need to do is make the aliens come forward 1 row towards us every time it touches the edge of the canvas. So here, I'm going to move all aliens up by 1 row. So let's use a for loop. For let j equals 0, j less than alien array dot length j++, I'm going to do alien array of j. So you want to be careful here because little I and little j look alike. So I'm going to do alien array at index j. I'm going to set the y position plus equal alien height. So it's going to move 1 row forward. And the height is basically the same as the tile size. All right, so if I refresh the page, you can see the aliens are moving towards the right, and it touches the edge, so it's going to go down 1 row and reverse course. All right, so you can see the aliens are going down 1 row each time. So one thing you might have noticed is that the aliens are moving out of place, and it's usually the first alien that touches the edge. So it's because it's moving 1 forward, but as soon as it touches the edge, the rest of the aliens are going in the opposite velocity. So they're out of sync. So to resolve that, I'm going to do alien.x. So right after we change the velocity, I'm going to do plus equal alien velocity x times 2. So we take 1 step forward and 2 steps back. So if we take 1 step forward and 2 steps back, that means we're taking 1 step in the opposite direction. So this is going to be in sync with the rest of the aliens. All right, so if I refresh, you can see every time the aliens move down 1 row, they are in sync. Okay? So now that we have our aliens moving, and we can also move the ship, we need to start firing at the aliens. So I'm going to scroll back up, and under aliens, I'm going to add some variables for the bullets. So we're going to have multiple bullets, and just like the aliens, we're going to need a bullet array. Now the bullets are going up, so they're going vertically. So we're going to have a bullet velocity y, and I'm going to set this to -10. So this is the bullet moving speed. And remember, it's -10 because we're moving up. So the top is 0, and the bottom is the board height. So we need to move up, so we're going to have a velocity of a negative number. All right, so now that we have our array and our velocity, let's create a function called shoot. So this is shoot, and it's going to be a function that takes in a key event. And similarly, we're going to check for a key. So in this case, we're going to have the user press the spacebar to shoot. So I'm going to type if e.code is equal to space, we're going to shoot. So we're going to create a bullet object. Let bullet is equal to, we're going to have an x. So this is going to be ship.x plus ship width times 15/32. So this might be a little weird, but this is going to place the bullet x position directly in front of the cannon. And the y axis, which is the vertical axis, this is going to be the same as the ship.y. The width, I'm going to make it 1/8 of the tile size. So it's going to be very thin. And the height is going to be tile size divided by 2. And I'm going to give it an extra property of used, and I'm going to set it to false. So whenever we shoot a bullet, we create a bullet object, and used basically means if the bullet touches an alien. Because if we don't have this, the bullet can fire through the alien and not be consumed. So the bullet is just going to keep on traveling and pierce through all the aliens in the column. So for this reason, we're going to add a boolean that checks to make sure that the bullet has been used. So we're going to do bullet array, and we're going to push the bullet in. All right, now that we've created our shoot function, let's add it to a key event listener. So I'm going to scroll up. Right below move ship, I'm going to do document.add event listener, and it's going to listen for a key up. So we're going to call shoot. So the difference between key up and key down is you just need to tap on the key and you can hold on to the key, because as long as you're holding on to the key, it is a key down. With a key up, you need to tap on a key and let go. So the key needs to be released. That way, you're not holding on to a key to fire. Instead, you're going to have to tap rapidly, like this. Okay? All right, so now that we've created our function to shoot the bullets, we need to draw the bullets. So down here, I'm going to add a for loop for the bullets. We're going to add a for loop for let I equal 0, I less than bullet array dot length, I plus plus. We're going to get the bullet at that index. So bullet is equal to bullet array at index I, and we're going to set the bullet Y position. We're going to increase it by bullet velocity Y. So you may notice that we don't have an image for our bullet. So I'm going to do context.fillStyle. We're going to set the color to white, and I'm going to draw a rectangle for the bullet. So context.fillRect, bullet.x, bullet.y, bullet.width, and bullet.height. Alright, so if I refresh the page and I tap the spacebar, you can see I am firing bullets. Now here's an issue. I can keep firing bullets and the bullet array is going to constantly increase in size. So what I need to do is I need to make a check to see once the bullet has been used, or once the bullet has passed the top of the canvas, it becomes useless, right? So it's an object that is in memory, but it's just useless, and it's going to accumulate over time, and eventually our game is going to start slowing down. So over here, right under our for loop, I'm going to add a while loop. So it's going to clear the bullets. So while bullet array dot length is greater than 0, this means we have bullets active, and bullet array of 0, which is the first bullet, dot used, or bullet array of 0 dot y is less than 0. So if it's less than 0, if the y position of the bullet is less than 0, that means it went above the canvas. I'm going to do bullet array dot shift. So this removes the first element of the array. Alright, so now we can keep on firing, and you can see every time the bullet goes past the canvas, it's going to get cleared. Now we need to actually make the bullets touch the aliens. So I'm going to add a collision detection function. So to detect collision, I'm going to create a function here called detect collision. And we're going to take in A and B, and these are two objects. And I'm going to return a Boolean. So this is going to be a set of conditions. A.x is less than B.x plus B.width. So this means A's top left corner doesn't reach B's top right corner. A.x plus A.width is greater than B.x, and so this is A's top right corner passes B's top left corner. A.y is less than B.y plus B.height. So this is A's top left corner doesn't reach B's bottom left corner. And finally, A.y plus A.height greater than B.y. So this is A's bottom left corner passes B's top left corner. So this is the condition for checking collision between two objects, two rectangles. So now let's scroll back up. And within our for loop for our bullets, I'm going to add another for loop for the aliens. So this is for bullet collision with aliens. So for each bullet, I'm going to loop through the alien array to see if there's any collision between that bullet and the aliens. So let's iterate through the aliens array. So let j equal to 0, j less than alien array, dot length, j++, and I'm going to get the alien at index j. So alien array of j. So first we need to check, has the bullet been used? So if not bullet.used and alien.alive, so the bullet has to be unused and the alien needs to still be alive, and detect collision of bullet and alien, we're going to set bullet.used to true, alien.alive to false. We're going to deduct the alien count by 1. Okay? Alright, so if I refresh the page and I start firing at the aliens, you can see they start disappearing one by one. Alright, so we have a functional game of Space Invaders, but we want to continue playing. So I am going to add more aliens. Down here, after clear bullets, I'm going to call create aliens. So I'm going to check for the next level. If alien count is equal to 0, we're going to increase the number of aliens in columns and rows by 1. So starting off, we have 2 rows of aliens, and each row has 3 columns of aliens. So I'm going to update alien columns, and I'm going to take the min of alien columns plus 1 and columns divided by 2 minus 2. So the reason why I am adding a min condition here is because if I keep on adding aliens one by one, if I keep on adding a new column, eventually it's going to pass the canvas width. For that reason, I'm going to take the number of columns divided by 2 and subtract 2. I divide by 2 because each alien width is 2 tile sizes. And I do -2 so that we always guarantee space for the alien to move left and right. So what does this mean? The cap is going to be at 16. We have 16 rows divided by 2. So that's 8, and we subtract 2. So we're going to have at most 6 columns of aliens. Let's also do something similar for the alien rows. So math.min of alien rows plus 1 and rows minus 4. So I'm going to make sure that the aliens do not exceed up to 4 rows above the bottom of the canvas. So if we kept adding onto the rows, eventually they're going to reach the ship. So we want it to still be playable. So we're going to cap it at 16 rows minus 4. So we're going to have at most 12 rows of aliens. And just to make it extra fun, I'm going to take the alien velocity x and increase it by 0.2. So this is going to increase the alien movement speed for every level. And then I'm going to call create aliens. But before I call this function, I want to clear 2 things. One is the alien array. So I'm going to set it to an empty array. And 2 is the bullet array. I'm going to set this to the empty array as well. And the reason is, if I keep firing bullets and I clear the aliens, eventually when I create new aliens, one of the bullets that I fired previously might touch one of the aliens. So you're going to have a group of aliens with maybe 1 missing. For this reason, we want to clear the bullets. Alright, so if I refresh the page, I'm going to start firing at the aliens. And you can see more gets generated. Okay. And they're increasing in speed every level. So you can see we've reached the maximum column, which is 6. So let's keep on going. So we can play this game forever, but we want something to motivate us, and that is the score. So we want to clear as many aliens as possible and improve our score. So we need to keep track. Alright, so let's scroll back up. And over here, right below bullets, I'm going to create a variable score and set it to 0. And actually, I'm going to create another variable called game over and set it to false. So let's start with the game over variable. So in our update function, over here, I'm going to add if game over return, because there is no longer any need to draw on the canvas if the game is over. And down here, move ship, I'm going to check if game over return. So we're going to make it so that the player cannot move the ship if the game is over. Okay, likewise, in our shoot function, we want to prevent the player from shooting if the game is over. So if game over, return. Okay, so when is game over? The game is over when the aliens reach the same row as the player. So right under draw image, I'm going to do if alien.y is greater than or equal to ship.y. Game over, we're going to set it to true. Okay. All right, so we have our game over condition. Now let's update our score. So over here, in right below next level, I'm going to paint the score. So score is going to be context.fillStyle. We're going to make the color white. Context.font is going to be 16 pixels, courier. And I'm going to do context.fillText, score. We're going to make the X position 5 and the Y position 20. So you can see I have the score on the top left, and if I shoot the aliens, we forgot to increment the score. Over here, in our bullet collision with the aliens, after we decrement the alien count, I want to increase the score by 100. Alright, so if I refresh the page, you can see when I shoot an alien and kill it, our score increases by 100 per an alien. And when I defeat a group of aliens, a new group appears, and each group increases in size each time. Okay, so we have our fully functional game of Space Invaders. And as you can see, game over. Okay, so the aliens have reached the same row as the ship. Alright, now that we have a fully functional game of Space Invaders, this is where the video tutorial ends. So before we go, I want to challenge you to continue working on this game after this video. So the first challenge, I want you to add a feature that would give each alien a random color. So we have 4 different colors. We have white, cyan, magenta, and yellow. Currently, all the aliens are the same color. So I want you to add a feature. When you create the aliens, I want you to assign each one a random color. For the second challenge, I want you to make the aliens fire back at you. So currently, you can shoot bullets at the aliens. I want you to make the aliens be able to shoot at you. So you can make this random so that randomly in one of the columns, an alien will fire at you. Okay, so this is going to be a little more difficult than the first challenge. Alright, so that's it for this video. If you found this tutorial helpful, please give it a like and make sure you subscribe for more videos like this. And I'll see you in the next video. Bye bye.